let's start with something simple to begin with. So let's suppose I have something like sine x equals a half, and x is between 0 and 360 degrees, like that. So what I'm looking for here is the x that would make this true. So the sine of some angle will be a half. Now we kind of have an idea how to get this on our calculator. What function do we use in our calculator to get this? Sine inverse. So what angle is that then? 30. So is it 30? I know that, but which is it?
I think it's 30.
It's
30, okay. So I want you to type in sine 30 on the calculator. What do you get? Just confirm that you get a half.
Yes.
Yeah.
You do get a half. Yeah. Now, the only problem with that is that the calculator has only given you one answer, but there actually might be more than one answer. So, see what happens if you type this in. Sine 150. Also a half. Yeah? Yeah. So, say again? Yeah, go on, yeah. Yeah, that's it, yeah. So, no, there's only the two, I think. Yeah. So, my point here is that the calculator only gives you one answer, but there's actually more than one. There's two answers here. 30 or 150. Yeah. Now, we need some way to figure out how to get the second answer, because you might be wondering, how did I know that the other answer was 150? The calculator gave us the first answer. All you typed in was sine inverse a half, and that gave us the first answer of 30. So how do we get the second answer? 180 minus, yeah. So you'll need to write these three facts down. For sine, if you want to get your second answer, it's 180 minus the first answer. For cosine, if you want to get your second answer, it's 360 minus the first answer. And for tan, to get the second answer, it's, does anyone know this one? It's 180 plus the first answer. Okay? Now this isn't in the formula book, you'll need to make a careful note of this. Okay, you got those three? Yep. Yes, got that? Okay, so let me just give you a short one to try, just to make sure you've got it. Give me the two answers to this equation, where of course again x is between 0 and 360 degrees. So I want you to try and solve this one, okay? It should only take you a minute.
$330.
330 and 30, yeah? Okay, so if you type in cos inverse root 3 over 2, does that give you 30?
Yes.
And then the second answer, according to my list, is 360 minus the first answer. So 360 minus 30 is 330. Okay, can I scroll down a little bit? Now, and there's a circle that a lot of you would have seen in high school or middle school, and as soon as I draw it, I'm sure many of you will recognize it. Yeah, memories, huh? Coming back to you.
All students strike cigarette.
My one we learned was all students take care. But whatever 4 letters you do, that's fine. Or whatever 4 words you have, that's fine. So this is a useful little circle for helping you remember some facts about sine, cos and tan. So this quadrant here represents 0 to 90. And the A here is telling you that all of them, sine, cos and tan, between 0 and 90 is a positive number. Okay, so if I type in like sine 45, cos 60, tan 80, I know all of these will be positive in this quadrant because that's what the A is reminding me here, that they're all positive. Okay. In the second quadrant, only the sine is positive. So for example, in this quadrant 2, between 90 and 180, if I type in, let's say, sine 100, that will be positive. But if I type in, let's say, cos 100 or maybe tan 100, they will be negative. Yeah? Yes, okay? Yeah. Now, what about the third quadrant? You kind of see the pattern here. Only tan is positive. Yes? And sine and cos will be negative. And in the last quadrant, only cos is positive. Okay. Now, what's the deal with these little 4 theta's here? So this is to help me remember something about the value. So, for example, if I draw the circle here like this, and let's just say I call this angle 10 degrees. This angle here is 10 degrees as well. So if this is 10, then how much is it over to this angle? Because this is also 10. 180 minus 10, which is 170. Okay. So what you're saying here at the 170 mark is that the sine of 170, cos of 170, tan of 170, they will all be very similar to sine of 10, cos of 10, tan of 10. How will they be similar? Well, they'll actually be the same value, but they only differ in the sign. So, because sine is positive in the second quadrant, it means sine of 170 and sine 10 will actually be the same number. And you could check this on your calculator. Sine 10 and sine 170 are. Cos 170 and cos 10 will be the same number, but the cos 170 will be a negative. And the tan 170 and the tan 10 will be the same number value, but opposite in sign again. Now, if you think about it, you can actually produce the rules I gave you. So what you're saying here, sine is positive and sine is positive in the first and the second quadrant. So that means that this will have the same value of this. So if you have theta or 180 minus theta for sine, you'll get the same value. And you can see the same thing for cos as well. So this one here is the same as this one. Okay. How do we get this angle? Well, it'll be 360 minus theta. Well, this is what we also said previously. And, yeah? 360.
Yeah, that's 350, sorry.
Oh, yes, so in the case of tan, it would be 350 then, yeah. And lastly, with tan, which quadrant is tan positive in? The third one. So if you start here, the next time you get the same value of tan is when you're exactly opposite, which is 180 degrees across from it. Okay. Now, you don't have to use this circle. I actually don't use this circle ever, except for right now, just to show you, because for me, it's enough to do all the problems in the exam by simply just remembering these 3 facts. But you know, some people like to remember by statements and some people like to remember by pictures. So you can either remember it simply as these three facts, or you could remember it as this picture. If you ask me a question like, teacher, how does this circle work? I'll tell you, leave me alone because you don't understand it. You need to remember it this way then. Okay? So I am only showing you this not because it's actually on the course, but because some of you have seen it already and prefer to remember things like this. If you don't like it, then don't remember it. Just remember these three facts, because that circle represents the same thing as these three facts that we need. Okay? You want 10 minutes. You want to take a picture of the circle, change your Facebook profile to be the picture of the circle, and say, I am the ASTC circle. Yeah. Status update. Got that? Yeah. Okay, so let's look at one that's a little bit harder now. Scroll down. Right, so let's say this one here. 2 sine squared x minus 3 sine x plus 1. And again, we'll keep the x to be between 0 and 360. Okay, so I'm sure some of you have spotted already what's happening in this particular equation. What type of equation is this when you look at it? It's a quadratic, except the variable is not x, rather sine x. Right, let's see if we can factorize. It has to be a 1 and a 1 at the back. Has to be a 2 sine. So the question is just if it's plus or minus, both minus, I believe. Yeah. Right, well, this is all very familiar territory to us. So it means on the left we have 2 sine x minus 1 equals 0. And on the right here we have sine x minus 1 equals 0. So yeah, so you get sine x equals a half, sine x equals 1. So here this is 30. We actually have this one already. It's 30 and 150. Sine inverse of 1 is 90. And the second answer is 90, because it's 180 minus 90. So actually, repeated, it's redundant. So we have 3 answers to this equation. So either x is 30, 90, or 150. Okay, so that's a quadratic one. Write this example down now, and we'll have a look at 2 more examples here. Or maybe 3 more examples, yeah.
The ones that we can't factor in the quadratic formula?
Yeah. The one, if you can't factor it, you can just use the formula. Okay. Continue? Yeah? Yeah? Got that? Okay. So, next one now. So let's just make these equations, start making them a little bit more difficult. So suppose you have sine 2x equals a half, and x is between 0 and 360 again. The 2x, does anybody know, would it make more or less answers? There's not 2 answers to this one. Does anyone know how many answers it will have?
1.
Yeah, you're saying 1? So
Because it's not 2.
it's not 2, yeah, it's not 2. So you're going with 1. How many do you think?
4. I think
It's just
No,
yeah, double, yeah. 4, yeah. It's roughly double. Well, it should be up to double because of the 2 here. Okay. Now, how can we solve this? Well, actually, you realise that if you just simply think of 2x as an angle, you have the same type of equation. Sine of an angle equals a half. So that means the angle 30 or 150, like what we had a moment ago. But the angle is actually 2x, so 2x is 30 or 150. Now, there's actually a small problem here because there's actually 4 answers to find, and there's only 2 that we have here. And I only showed you how to make 2 answers. So we need a way to make 2 more answers. Not multiply by 2, good try though. Yeah, plus 360. Because if you think about it, let's imagine that 10 degrees is an answer, okay? Well, if 10 degrees is an answer, then so is 370 degrees. Because you're back at the same angle on the circle, so you should have the same value, okay? So simply by adding 360 to these 2 answers, we can make 2 more. So that would be 390, and what's that? 360, 460, 510, yeah. But that's for the angle, and the angle is 2x, and we need x. So, lastly, I should divide by 2. So I get 15, 75, 195, and 255. Yeah. So those are my 4 angles. Like that.
Will it also be correct if you multiply the 0 is less than x less than 360 by 2?
Multiply this by 2.
Yeah.
No, but kind of similar to that, you could say, I guess you're right. You could multiply this by 2, and you could say 0 less than or equal to 2x less than or equal to 720. And the 2x is what you're calling the angle for this problem. So you should have 4 angles between 0 and 720. Yeah, that's fine. Yeah. Yeah.
Why did you divide it by 2?
Oh, it's only because we're actually looking for x, and this is 2x. So in the last step, it's like I divided everything by 2.
So we can add more points, right?
You can add as many as you like. The condition is that your 4 answers must be between 0 and 360 in the end. Yeah.
So if it was 3x, it would be adding 540.
You'd have to add 360, 360, and then 720, 720. Yeah. Okay, continue.
Including 360, yeah? So 360 would be about...
It depends on what they specify as the domain in the question. You notice in my questions I kind of clip out the 360. I only include the 0. Because 360 is the same as 0 on the circle, so I don't want to include both 0 and 360. Okay. Continue? Yeah? So, just a little quick rule here, which you might actually know already. So if there's a right angle triangle, opposite, adjacent, hypotenuse, okay? Pythagoras said opposite squared plus adjacent squared equals hypotenuse squared. If I divide everything by the hypotenuse squared, I get O squared over H squared plus A squared over H squared equals 1. But O over H is sine. Yeah, sine squared plus cos squared equals 1. This is actually a very useful formula because it lets you switch between sine and cos squared. So for example, if you had sine squared x, you could change that into 1 minus cos squared x. And if you had cos squared x, you could change it into 1 minus sine squared x. So it's actually a very useful formula. Can you write this down? We'll do an example where we need to use it next. Got that? Okay.
There's also one for tan.
Yeah, we don't actually need it in semester 1. Cotan 1, yeah. Yeah, that's semester 2 trigonometry, I think. Got it? Yeah. Okay. Scroll down. Yeah. Yeah. Okay. So let's say we have something like let's say we have something like 3 sine x plus 2 cos squared x minus 3 equals 0. And again, x is between 0 and 360. So the problem with this equation is you have a mixture of sine and cos. So which one do we change here? There's actually only one of them we can change, the cos squared. We change it into 1 minus sine squared. So that's 3 sine x plus 2 minus 2 sine squared x minus 3 equals 0. If I take everything to the right, I'll get 2 sine squared x minus 3 sine x. 3 minus 2 is 1. Yeah? And I believe you seen exactly this one just a minute ago. Isn't that the quadratic we did? Yeah. So there's obviously no need for me to repeat how to solve this. What did we get? 30? What was it?
30, 90, 150.
30, 90, 150. Okay, have that. Yeah. Now, one more example to do. So, all my examples I've done so far have been in degrees. It's no big deal because if you're using radians, it just means instead of using 360, you use 2 pi. But of course, you need to remember to put the calculator in radian mode. So I'm going to do an example. It's a little bit trickier because it has a few steps in it. But it's a good example for making sure you have the steps in the right order. So if I just write down here, let's say 4 tan minus 3x plus 2 pi over 9 minus 1 equals 0. And this is where x is between 0 and 2 pi. For this one here. Now, it's very important that you do the steps in the right order. So what I mean is earlier, where's it gone? Here, we divided by 2 at the very end. Some people might think, well, I'll just divide by 2 at the beginning and then add 360 on afterwards. And you don't actually get the right answer if you do it that way. So there is actually an order for doing these. And I try to remember it just as 4 letters, i.e. S and F. So the first thing you need to do is get a tan inverse. Then you get the extra answers. Then you simplify, like divide by 2. In this case, we'll have to divide by 3. And then lastly, you fix any answers that don't work. And I'll have to explain what that step is because we haven't seen a problem where that has happened. So first, the I step. So I can rewrite this as tan. If you want to think about it like this, tan of an angle is equal to 1 over 4. If I just bring the 1 over and divide by 4. Now in radian mode, what is the tan inverse here of 1 over 4, please? Give me 4 digits. 0.2449. 2449. Now, to get the second answer for tan, you have to add 180, which means you have to add pi. So you have this, or, what's the... 3.386 then. Okay. Now, how many answers should you have here? 6 answers. 6 answers. So, we need to have, well, there's 1, 2, or 3, or 4, or 5, or 6. Okay. So, if you add 2 pi to each of these two, we can make 2 more answers. So, I've completed the first step.
6.528.
Okay?
Uh, 9.669.
Okay?
12.81.
12.81. Oh, hang on.
Wait, what's the rate for the answer?
There's only one left. So the last one now. 15.95. Great. So you've done the second step, which is to make the extra answers. Now on to the simplifying step. So are these 6 answers for x? No, they're for the angle. And the angle is minus 3x plus 2 pi over 9. But we don't want this angle, we want x. So think about it like this. If you rearrange this, you could say 3x equals 2 pi over 9 minus the angle. So that means x will equal 2 pi over 27 minus the angle over 3. So in other words, you can change this angle into x if you apply this simplification to the 6 answers here. So if you take these 6 answers and do 2 pi over 27 minus the answer over 3, you get the value of x. Okay, so I'll need to split this up. That's 9.669 here, I think. Yeah. So I'll let you two guys do the first 2 for me, and then Amjad, could you do the third one? And can you two guys then do 4 and 5? Yeah. And Michelle, could you do the last one here? So 2 pi over 27 minus 15.95 over 3. If you can give me the decimal for that. Which one?
This one.
12.81. Yeah.
What does the I stand for?
Inverse. Oh, the I at the start of this one. Yeah, so that's type in tan inverse on the calculator. Yeah. Right, who's giving me the first one here?
I'm not sure if son's not happening.
Who do I ask to do the first one? Yeah, no, Mo. It's just 2 pi over 27 minus the angle over 3, and this is the angle I want you to. Yeah. You follow fine. Wait, I want to do them in order.
Which one did you do?
He's doing the second one.
I did the first one.
Alright, what is it?
It's 0.151077.
I'll do 3 significant figures, so 0.151.
Yeah.
Okay. Or, you're doing the last one. What did you get for the well, no, I'll do it in order. Who's got the second one?
Oh wait, is that 9?
Yeah.
It looked like 27 for a second. Then the answer is 0.61649.
616. Okay, Mo? Oh, come on, Mo.
I have to put in brackets and just calculate in my calculator.
And you need to
The answer
wind it up on the side as well.
It's minus 0.
Minus 0.89.
Minus 0.8959.
8959.
So 6 then. Okay, who has answer 3 for me? Is that you, Amjad?
Yeah.
What you got?
Negative 1.942.
Minus 1 point.
942.
Okay,
First
943.
one is 0.1551.
Oh!
Yeah, so it's the first answer.
Can't trust you. What is it?
0.151.
Yeah.
Okay, thank you.
Nothing else.
Right, who had the fourth one over here?
Negative 2.990.
990, okay. Fifth one?
Minus 4.04.
Okay, and Michelle?
Minus 5.083.
Okay, so we'll say 09 then. Right, now, guys, are you looking up, please? So, we've done the third step, which is the simplified step. So the last one is to fix the answers. Now, what do I mean by that? Well, we said at the beginning that x, yeah, greater than 0 and less than 2 pi. Only one of these answers is actually greater than 0 and less than 2 pi. Which is that? The first one, isn't it? So, it's not that we reject the other 5 answers. We can actually fix them. You see, imagine I told you the answer is minus 10 degrees. That's not acceptable because it should be between 0 and 360. But you realise that minus 10 is, yeah, it's the same as 350, isn't it? Now, how did you get that? You added 360. So, likewise, all these 5 answers are too negative. We can make them back into positives by adding 2 pi. So the last step, the fixing step, is you just want to add 2 pi to these 5 answers. So, you've got, wait, hang on, the first one is okay. So what's the next one?
5.387.
5.387? So 39 then. Okay. Next?
4.38.
4.38, okay, next?
4.
3.29? 2.25? And lastly? 1.19. So 1.19.
93.
Yeah, like this? Yeah. So all of them are fine. Yeah? Now,
The last number is 0. It's minus 5.08.
minus 5.2. It's okay. It's close enough, yeah. It rounded off to 0.8, was it? Yeah, okay. So there's a small error here for me. Yeah.
That's supposed to be 4.34.
Which one?
The 4.38.
4.38? Should be.
4.34.
Are you sure?
Yeah.
Okay, if you say so.
What?
Are you sure?
I know.
Come here.
Yes, you're right.
And Amjet's wrong?
That's the right, yes.
Dang. Alright, thank you.
There it goes.
So unlike Amjet to be wrong about anything. Yeah. Now, you can actually check this out. So what I'm saying is, if you took out your calculator and typed in 4 tan minus 3 and pick any of the 6 answers you want randomly, plus 2 pi over 9 minus 1, you should get 0. Now it won't be exactly 0 because of the rounding, but it should be very close to 0. So why don't you take, let's say, the third answer, 4.34, and see if you get close to 0.
So
Yeah.
that's not 2.25.
Which one? This one?
Yeah, 2.5.
I just did my answer plus 2.5.
Well, the problem is also with slight rounding, so maybe your previous answer.
I didn't round.
That's my point, yeah. Yeah.
4.4.
Huh?
Minus 4.037289.
Minus 2.024376
Yeah.
times 10 to the power minus 3.
10 to the minus 3. So that's 0.00. It's good. Yeah. Guys, listen up. Listen. 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 Shh. Listen. So, the problem with these questions is you can kind of have a little bit of a rounding error depending on how early or late that you round in the question. ideally you would like to round at the last step, but it's going to be a real pain to have to type the full angles, okay? Now, there is actually something on your calculator that can help you out a little bit here that I'll just show you. So, if you want to be more accurate, but you don't want to have to write the full angle out, there is a mode on your calculator that can help you store angles for you to use later, which I'll show you how to do that. I think all the Casio calculators have this mode. So once it opens up here. Now, like I was saying, if you were to pick any of these 6 angles and sub it into your equation, you should roughly get 0. I think when you typed it in, he got something like 0.001.
But I got a negative.
That doesn't matter, like a small positive or a small negative. It won't be exactly 0 because you had to round it off. Now, let's imagine, let's take the first answer. What was it? 0.2449. That was shift mode radian. Okay. Shift tan inverse a quarter, wasn't it? So that was it there. So it wasn't actually 2249, it was 22497. Now, maybe you want to be more accurate, but you don't want to write all this down. You can store this in the letters A, B, C, D, E, and F. So if you type, where's my store button? No, I need store. Yeah, where's store on this? I can't see it. Oh, there it is. So, shift, store, A. Now, that angle has been put into A. So watch, I'll do it again. Shift, store, A. So that number on the screen is now in A. So if I clear the calculator and go down here, what did I do to get 0.151 here? I applied this, didn't I? Yeah, so you could do 2 pi over 27 minus the angle over 3. But you have the angle stored as letter A. So if you do alpha A here, then it should give you the exact answer here. And you could do this for A, B, C, D, E, F. You have up to 6 memory locations on the calculator. What was the last thing we did? Nothing, we just kept it for the first one there anyway. So let's test it out. Let me store this as B. Shift, store, B. Okay, so 4 tan minus 3 alpha B, which is this exact angle here, plus 2 shift, where's pi gone? Pi over 9 and then minus 1. So what should I get here? 0. Which I do. Exactly 0 because the calculator stored all the digits. Okay. So this store function is very convenient, especially when you want to store 6 long numbers, because you have A, B, C, D, E, and F, I think, is your choice here. And they don't usually do more than 6 in the exam anyways. Okay. Everybody has a store function on their calculator. Yeah. You should practice using it. It's a very convenient function for helping you be more accurate. Okay.
The X, Y,
the X, Y one. Are they store functions as well? I don't know because I've never used those ones. So I know A to F is. They're stores as well? Oh, wonderful. Okay.
It does not have the green brackets.
Which ones?
X, Y, and F.
It doesn't have what?
There is green brackets.
What's the green brackets? What do you mean?
A to F has green brackets. X and X.
Oh yeah. Well, there might be something else you can do with X and Y as well as just storing it. Okay. So what I'd like you to start now for a few minutes is all of question 1 because it's quite short. And then from number 2, I just want you to do ABC. Right, listen. I'll say it again. I want you to do all of question 1, and then in number 2, I want you to do ABC. And If you like, you can do for extra practice 3A and 4. But for the exam, they don't get any harder really than question 1 and 2 ABC. Okay, so can you start those now for a few minutes, please?